I'm going to talk a little bit about how we could measure the effectiveness or the performance of a search engine. So one measure that you could perhaps use is the speed at which a search engine indexes documents. Okay, so you could do this in terms of the number of documents that are indexed per hour, right? So obviously search engines which use distributed indexing are going to perform much better than search engines that try to um, distributed indexing also not only allows you to build your index on large corpora, but it also allows you to do the indexing fast. Dynamic indexing allows you to keep updating your index as new documents appear, right? So search engines which have those kind of features are obviously going to be better in serving results to the users than those which don't. um, And so we've looked at paradigms like MapReduce for distributed indexing, which, help large search engines speed up their indexing process. So that's one way you could measure it. Another way you could measure it is you could look at how soon the results are returned when you submit a query to a search engine, right? And if you want to focus on this particular, on improving this particular time, then you'll have certain design choices to face. For example, last time we looked at the query parser module, and I told you that for spelling correction, one possibility is that the query parser could submit a query to one of the indexes, look at how many results are returned, and then uh, you know uh, if the number of results are not very large, then it will ask the spelling correction module to do its task. But that could be slow, right? Um, so it's possible that a query parser could submit the query to a normal index and also ask the spell corrector to do its job. But in that case, you will be sacrificing uh, computational power for time. So you will gain in terms of time, but you will have to do a lot more computational work. So there are trade-offs there also. How expressive your query language is, whether you can serve wildcard queries or not, uh, whether you can have complex Boolean operators in your query language or not. Those are some ways of measuring how expressive a query language is. And then the complex queries need to be served pretty fast. So these are different ways in which you could evaluate a search engine. Okay, how good a search engine is in indexing, how fast it is in indexing, how fast does it return the results, latency, and the expressiveness of the query language. And also important is how the search engine presents the results to the user. Okay, UI design also ends up playing a significant role. You can have an excellent search engine, but if the results are not being displayed properly to the user, then the user may not feel that happy with the results that have been served. That is why you have things like snippets and um, options for searching over related documents or searching for similar documents within the same site and so on. All those options are presented so that um, if you're not happy with what you've got, then you can just with one click uh, get those other kinds of results as well. But the most important measure for evaluating the performance of a search engine is user happiness. Ultimately, we want the user to find the information that he or she is searching for. So how do we measure user happiness? Well, to some extent at least, how fast the index is built, how much it's being updated every day, what's the latency in terms of the response. Um, all these end up contributing to user happiness, but ultimately the results that are returned have to be relevant to the user. Only then will the search engine be deemed as effective. Okay. So you can have a search engine that's blindingly fast, but that serves useless answers to a user, and that's not going to be good enough. So having all these other factors but not returning relevant results is not going to be um, satisfactory to the user. So in different contexts, you can measure user happiness in different ways. In the context of web search, the user is searching for information, and you can measure user happiness by keeping track of whether the user clicked on the results that were returned or not, whether the user spent enough time browsing the pages that were returned or not, and whether the user refined the query or not. These are some informal ways of keeping track of whether or not the user is happy with the search results. Of course, ultimately what matters is what the user is doing with that information, and what the user may be doing with that information could be some actionable item, like for example trapping mice, which was the example we saw in chapter 1, which you may not be able to measure online, of course. So in the context of web, these are some of the things that we may be interested in. In the context of an e-commerce site like Amazon or eBay, for example, we want to measure user happiness based on whether or not the user ended up buying a product on that site or not. Okay, and how much time it took for the user to purchase that item. The fraction of users who actually ended up performing a transaction on that site. So this is how user satisfaction would be measured in the context of an e-commerce site. Then in the context of enterprise search, you want users to find the information in the least amount of time. Okay, and if you're able to do that, then the idea is that the user will be more productive. Although that's not necessary, because if some piece of information that the user would have taken 5 hours to find can be found in say 30 minutes used by building an IR system, then the user is technically saving 4.5 hours, but of course it's doubtful whether the user will use the remaining time to be productive or not. Security is also something that needs to be kept in mind in an enterprise domain, because not all the users may have access to all the documents. So here's one question for you. Based on what we've discussed in the course so far, how would you add some kind of primitive security mechanism to your IR system? Let's say you have a company, and the company has an enterprise search system built on a corpus of documents that are private to that company. And different people in that company at different positions have access to different sets of documents. So is there some simple uh, technique that you can think of by which you can uh, return results to each user only based on what that user is authorized to see or not?
So we could tag the queries with the user who made the query, and with each document you could have an access control list, so that in the index level itself, rather with each document you can have an access control list and see whether the query is applicable on that document or not based on the user.
Yeah. So an access control list is basically, I mean, think of yourself as building another index. That's good actually. So I think you've read chapter 6 properly. I didn't cover access control lists in chapter 6, but uh, basically think of building an index for each user where the terms of the index are the uh, names of the users, say the login name of the user, and the postings list contain doc IDs of documents that the user has access permission to. And so you build an IR system which will return a list of documents, but then at the final step you take the intersection of the list of documents with the access control list of the user who submitted the query. And so the documents that the user was not authorized to see would get filtered out in this way. Right? So that's a simple mechanism you can use to serve differential results to different users. So you can turn off the microphone. Actually, here's another question. How would you build a video search engine like um, like YouTube, for example, where you have instead of indexing text documents, you're indexing video documents, or sometimes you may even want to index images. So if you want to do image search or video search, how would you do that using the techniques that we've discussed? I mean, let's say you were just asked to come up with, let's say you were asked to design a video search system in, I don't know, 10-15 minutes. How would you do that? By design, I don't mean actually, build the system, but just come up with a diagram of what your system will look like, or a description at a very high level.
Hello.
Hello? Yeah.
Sir, we can do something like we keep our videos in the database and we give a proper name with the keywords that we most likely search for the video names, the tags. So then the search engine can get those tags as per the query. Like if I search for networking or CCNA, something like that, so all videos regarding CCNA will come up. If we search for data mining, particular videos that relates to data mining will come up with the tags.
Yeah.
Something like.
Yeah, and how do you add the tags if you don't have?
Sir, on the
yeah.
On the the title of the video, like on basis of what we're indexing the video in the database, we keep the name of the video something that has the keyword within the name. So suppose data mining, information retrieval video 1, information retrieval video 2. So information retrieval is there. So whenever a search query for information retrieval happens, it will pick up all the videos that are listed.
Okay, so title is one of the tags.
Yeah.
But the other thing you could do is, as on YouTube, you can add your own tags. So when uploading a video, you can decide what list of tags you want to, associate that video with, so that anybody who's searching for any of those tags, it doesn't have to be a tag in the title. It can be any number of tags, and someone searching for them will usually find that video somewhere or the other in the ranked list.
Okay, sir.
Right. So you won't be indexing the video itself, but you will be indexing the metadata associated with the video. And you can think of tags as a kind of metadata. Okay, you can turn off the microphone. So the way to measure user happiness is to look at the relevance of search results. Okay. And if you recall from chapter 1, relevance is something that is measured with respect to the information need of the user, not with respect to the query. But however you define relevance, I mean whether you measure it with respect to the query or with respect to the information need, we still need to calculate the relevance. And how do we do that? Well, we will have a benchmark document collection. So let's say you build some kind of a search system and you want to evaluate its performance. To do that, you will choose a benchmark document collection. Okay, this could be, say, the Reuters corpus that we looked at earlier, or the New York Times corpus, or some predefined set of documents. And then you'll have a benchmark suite of queries. Okay, these are representative queries that users would have entered on that for that document collection. And then somebody has to sit down and do a binary assessment of whether the documents returned for each of the queries in this suite are relevant or not for every query and for every document. Okay, so as of now, you can just think of it as a binary assessment. So there will be some kind of a relevance or a QA engineer who will who will browse the results that are returned and mark each document in the result as relevant or not relevant. And he or she will do this for every query. So if you recall the term document incidence matrix where you have uh, terms along the rows and documents along the columns, similarly you can think of some kind of a relevance matrix where you have queries along the rows and documents in the corpus along the columns, and an entry in the matrix is either relevant or not relevant. It's relevant if that particular document is relevant to that corresponding query, and it's not relevant otherwise. Okay, so you can think of visualize conceptually this kind of a matrix.